Hi everyone, and you are welcome to the first lecture in this course, Introduction to Programming. In this lecture, I'm going to define what a computer is, I will show you what the main computer components are, and I will talk about the language that the computer can understand. After that, some important concepts will be defined, like a programming language and a program. Then we will talk about translators and translators types, and we will see how programs are executed on computers. Finally, I will end out this lecture by a quick summary. So let's get started. First of all, let me tell you that this lecture is for absolute beginners who want to learn programming for the first time. So if you find these outlines very familiar to you, feel free to move to the next lecture. Let's start talking about computer. So what's a computer? Computer is an electronic device that's able to store and process data according to the given instructions through programs. From this definition, we can understand that the computer does two main jobs. The computer stores data and processes this data. Maybe now we ask ourselves, how does the computer understand what to do? Let me answer you. Simply, we tell the computer what to do through some provided recipes, and these recipes are known as programs. From the previous slide, we see that the computer can do two main jobs. It stores data and processes this data. The question now is how the computer can do that. In fact, computer has several components enabling it from doing that. In my point of view, computers are very similar to humans, where we, as humans, usually we use our brains to process the data that we receive through our eyes, ears, etc. Also, the computer has a CPU, Central Processing Unit, and this CPU represents the computer brain and it does all the required calculation and processing. Also, we as humans, we have a short-term memory and a long-term memory. In the computer, we have a RAM, and RAM represents the short-term memory. And we call it short-term memory because it becomes totally empty once the computer is turned off. Therefore, there is a long-term memory, and usually we use this memory to store the data that we want to keep even after we turn off the computer. Hard disk represents the long-term memory in the computer. So to summarize, CPU processes the data in the computer, and RAM and hard disk store the data. Now let's move forward and talk about the language that the computer can understand. In fact, computer can understand only the binary language. In other words, computer can understand only 1 and 0. So for example, if I want to add one number to another, I have to send add instruction, and this instruction should be encoded in binary language. So for example, add instruction will be 000011100010. If I want to subtract one number from another, also I have to send subtract instruction, and this instruction should be encoded also in binary language like what you see here. From these instructions, we can see that it's very hard for a human to remember all of these instructions, and it's very hectic to communicate with the computer using binary language. To overcome this issue, people have developed what we call high-level programming language. So programming language is a tool which we use to write programs that should be executed by the computer. I mentioned that these programming language are high-level because in this programming language we use English keywords to communicate with computers. And I know that right now, the logical question that comes to your mind is how the computer can understand English keywords if it understands only 0 and 1. Before I answer this question, let me define what a program is. Program is a set of commands written in a specific programming language in a logical order to solve a specific problem. The key point to be kept in our mind from this definition that usually we write programs to solve problems. Now let me get back to my question. If we write our programs using English keywords, how the computers can understand these instructions? The answer is very simple. When people developed a programming language, they also developed what we call a translator. And the job of the translator is to take our program, which is written in English keywords, and translates this program into binary code or the language that the computer can understand. So as you see here, the program that we write, and usually we call it source code, will go to the translator. The translator will translate this program and convert this program into binary language. And this program here written in binary language is called binary code or object code. Now, and after we understand what the translator job is, let's talk about translators types. Mainly, there are two types of translators. We have compilers and interpreters. First, let's start talking about compilers. Compiler scans the whole source code and translates the whole program at a time, and then this program will be sent to the CPU for execution. Whereas in case of interpreter, it translates the source code line by line. In other words, it translates one line at a time, send this line to the execution, and then it will translate another line and send this line again to the execution, and we repeat the same cycle again and again in the case of interpreter. The detailed comparison between compilers and interpreters are out of the scope of this course. Now let's see how programs are executed on computers. Let me assume that I have a program and it's already translated into machine language or binary language. The first thing will happen that this program will be loaded inside the memory. As we see here, we have multiple instructions inside the memory. After that, the CPU will read the first instruction, decodes this instruction, executes this instruction, and then the CPU will write the result of execution of this instruction to the memory again. So the cycle is fetch, decode, execute, write back. And this cycle is known as instruction execution cycle. The CPU will repeat this cycle for each instruction inside the program until the whole program has been executed. Now let's recap what we have learned in this lecture. First of all, computer has been defined, and we see that the two main jobs of computer is to store data and to process this data. After that, we see the main computer components, and we see that we have CPU, RAM, and hard disk. Then we talk about the natural language of computer, and we see that the computer can understand only binary language, which is 0 and 1. And to make the communication between the human and computer easy, people developed programming languages. And we see that a programming language, it's a tool to write programs, commands. Then we defined what a program is, and we see it's just a set of commands to solve a problem. And keep in your mind that we write programs to solve problems. After that, we see how computers can execute programs, and we talk about the instruction execution cycle, which include fetch, decode, execute, and write the result back in the memory. In this lecture, I'm going to define what an algorithm is. We will understand the difference between an algorithm and a program. Also, I will share with you a complete example about an algorithm. Finally, I will end up this lecture by a quick summary. So let's get started. Usually, when we have a problem and we want to solve this problem using computers, the first thing to think about is the solution algorithm. So what's an algorithm? Algorithm is an ordered set of defined steps in order to solve a problem and obtain a logical result within finite amount of time. From this definition, we can understand that the algorithm represents the steps that should be implemented inside the program in order to solve the problem. Usually, we formulate any algorithm by defining the inputs, the outputs, and the steps that map the inputs into the desired outputs. Also, a very important point to know that when a problem can be solved using multiple algorithms, and over the time, you will get the required experience to know the best algorithm quickly. And usually, we compare between algorithms using different factors, such as execution time. So for example, we say one algorithm is better than another if they achieve the same target, but it requires less amount of execution time. After we understand the meaning of algorithm, now we should be able to discriminate between an algorithm and a program. Simply, algorithm is just a problem solution description in which we define inputs, outputs, and the steps, whereas a program is just the actual implementation of that solution using one of the programming language. So the algorithm represents the solution, whereas the program represents the implementation. Now, to understand the idea better, let's take a complete example about an algorithm. Assume I have the following list, 1, 5, 3, 4, and I want to know the maximum number inside this list. You as a human directly you will say, the maximum number is 5. And it's a very easy problem for you because this list has only 4 items. But what if this list has 1 million items? It's very hard to be solved by you directly as a human, and you have to use a computer. So you have to start to think in the way that the computer thinks. In other words, you have to set a solution algorithm in which you have to define inputs, outputs, and steps. In this problem, the input is a list of positive numbers, and let's call this list L, and it has the following items, which are 1, 5, 3, 4. Whereas the output is the largest number in this list, and let's call this largest number N. The algorithm steps will be, first of all, I will set the initial value of N to be 0. Then for each number X inside the list, I will compare this number with the largest number, which is N. If I find that X is larger than N, I will update the value of N by the value of X. I know that the steps could be not very clear, so let me explain these steps visually. First of all, I have the following list, which has 1, 5, 3, 4, and I will set the initial value of n to be 0. Now I will compare the first item, which is 1, with n. It's clear that 1 is larger than 0, so I will update the value of n now to be equal x, which is equal to 1. And now the largest value found until now is number 1. I will do the same comparison for 5, and I will find that 5 is bigger than n, which is 1 in this case. So I will update the value of n by 5. If I do the same comparison for 3 and 4, in both cases I will find that the value is smaller the value of n, so the value of n will not be updated, and I will keep the value 5 inside the n. Now, because I reached to the final item, which is 4, no more comparison required, and the variable n will have the largest number, which is 5. And that's all for this example. Now let me summarize what we have learned in this lecture. First of all, an algorithm has been defined as an ordered set of defined steps in order to solve a problem and obtain a logical result within finite amount of time. Also, we say if we want to formulate any algorithm, we have to define inputs, outputs, and the steps that will map inputs to the required outputs. Also in this lecture, we have discriminated between algorithm and program. And simply we say an algorithm is just a solution description, whereas the program is the concrete implementation using one of programming languages. That's all for this lecture. Thank you very much for your time, and if you are available, join me in the next